Good morning, students. Today we will study laboratory test for carboxyl group, that is COOH group. The presence of carboxyl group in carboxylic acid is identified by following test. So first type of test are laboratory test. It is valid or used for water soluble substances. So in the litmus test, this aqueous solution means solution in water is prepared for organic compound which containing COOH group. If blue litmus paper turns red, which indicates presence of this acidic functional group in the given organic compound. So this test is also for phenols because phenols are acidic and they turns blue litmus red. So this is one of the laboratory tests for the presence of acidic character in carboxylic acid. The second test for carboxylic acid is sodium bicarbonate test. Sodium bicarbonate is NaHCO3. When in organic compound sodium bicarbonate is added, then brisk effervescence of carbon dioxide gas is evolved. The water soluble acid goes into the solution and gives the precipitate, which on acidification with concentrated HCl gives again carboxylic acid. This test indicates the presence of carboxyl group in carboxylic acid. The equation is RCOH is a general formula for carboxylic acid. When treated with sodium bicarbonate, that is NaHCO3 aqueous solution, then CO2 is given out as a side product. Similarly, H2O is also given out as a side product. Main product is RCOONA aqueous solution, that is sodium salt of carboxylic acid. It is formed in aqueous solution, and again the carboxylic acid is precipitated by adding HCl in it and gives the precipitate, that is the original substance of carboxylic acid in the form of precipitate. The side product is sodium chloride. Phenol does not evolve carbon dioxide gas with sodium bicarbonate. Hence, phenol and carboxylic acids can be distinguished by using sodium bicarbonate test. Next test used for the identification of carboxylic acidic property of carboxylic acid is ester test. So in this test, 1 drop of concentrated sulfuric acid is added to the given mixture of organic compound containing COOH group, and 1 ml of ethanol is also added. Then the reaction mixture is heated for 5 minutes in hot water. Direct heating is avoided on burner. So after this, hot solution is poured into the beaker containing water. Then we get a fruity smell of ester, and it confirms the presence of carboxylic acid in the given organic compound. The general equation is RCOH is a general formula for carboxylic acid. When treated with ethanol and concentrated H2SO4 is added, it is warm, then it gives the ester having general formula RCOOC2H5 here, or R dash plus H2O. So this reaction indicates the ester formation from the carboxylic acid. So this is one of the important tests for laboratory tests for carboxylic acids. Then next type of reaction of carboxylic acid is a formation of acyl chloride. Formation of acyl chloride. This acyl chloride having general formula RC double bond OCl. These acyl chlorides can be formed from carboxylic acid by reaction with PCl3, that is phosphorus trichloride, or PCl5, phosphorus pentachloride, or thionyl chloride, that is SOCl2. When carboxylic acid is heated with PCl3 or PCl5 or SOCl2, then corresponding acyl chlorides are formed. Then this thionyl chloride is preferred out of this PCl3, PCl5 and SOCl2 because the byproducts or the side products during this reaction are gases, and therefore they escape easily, and it is easy to separate this mixture from acyl chloride. So in this reaction, OH group of carboxylic acid is replaced by Cl. Equations are RCOH is a general formula for carboxylic acid. When treated with SOCl2 is a thionyl chloride. It is heated, it gives RCOCl is acyl chloride plus side product are SO2 and HCl. These are gases. Then the next is reaction with PCl3. Here 3 molecules of carboxylic acid react with 1 molecule of phosphorus trichloride. When this mixture is heated, then we get 3 molecules of acyl chloride, and the side product is POH thrice. This POH thrice is phosphorus acid. Then reaction with PCl5. This RCOH is a general formula for carboxylic acid. When treated with PCl5 and gives RCOCl is acyl chloride plus side products are POCl3 and HCl. Here POCl3 is phosphoryl chloride. Next reaction of carboxylic acid is a reaction with ammonia. Ammonia is NH3, and this reaction is called as a amide formation reaction because in this reaction the final product is amide. When carboxylic acid react with ammonia, first it forms ammonium carboxylate salt, which on further heating at high temperature decomposes into acid amide. General equation is RCOH, it is a carboxylic acid treated with ammonia, first give ammonium carboxylate salt having formula RCOONH4, which on heating at high temperature it gives RCONH2, it is acid amide. So this is amide formation reaction. Then next is this acid amide that react with ammonia. Acid amide react with ammonia. Equation is here RCOCl is acid chloride react with NH3, that is ammonia, and give RCONH2, that is acid amide plus HCl. So that is about the reaction of carboxylic acid with ammonia. Next reaction of carboxylic acid is a formation of acid anhydride. So monocarboxylic acid that contains one carboxyl group on heating with strong dehydrating agent like phosphorus pentoxide, that is a P2O5, and concentrated sulfuric acid give acid anhydride. This reaction is reversible. This anhydride is readily hydrolyzed into carboxylic acid, and the reaction is this is RCOH one molecule, similarly RCOH second molecule of carboxylic acid when heated with phosphorus pentoxide P2O5, it loses one water molecule and give RC double bond O, C double bond OR. This is acid anhydride. Here the side product is H2O. It immediately reacts with this acid anhydride and again gives the carboxylic acid. Therefore, this reaction is reversible reaction. Better yield of acid anhydride is obtained by heating with sodium carboxylate and acyl chloride. This RCOONA is a sodium salt of carboxylic acid, that is a sodium carboxylate. When treated with acid chloride, that is RCOCl, on heating, side product obtained is NaCl, and the main product in this reaction is acid anhydride, having general formula RC double bond O, O C double bond OR. This is acid anhydride. So better yield of this product is obtained by using these starting materials. Now the next reaction of carboxylic acid is decarboxylation reaction. Before that, this acyl chloride and sodium salt of carboxylic acid, these are prepared by reacting with carboxylic acid separately with thionyl chloride and sodium hydroxide respectively. So this is RCOOH is a carboxylic acid. When react with SOCl2, it gives acyl chloride. Similarly, RCOH is a carboxylic acid, react with NaOH and give sodium salt of carboxylic acid. This acyl chloride and sodium salt of carboxylic acid that gives acid anhydride and sodium chloride as a side product. Then the decarboxylation of carboxylic acid. So this is one of the preparation method of alkane, and the same reaction we had studied in 11th standard in hydrocarbons. So sodium salt of carboxylic acid, when it is heated with soda lime is a mixture of NaOH and CaO. Then we get alkane, that is a hydrocarbon containing one carbon less than the carboxylic acid. Equation is RCOONA is a sodium salt of carboxylic acid, react with NaOH and CaO. When this mixture is heated, then we get RH, and side product is a sodium carbonate, that is Na2CO3. This is a general equation. Then particular example is, if we take this R group as a CH3 group, then this is CH3COONA is a sodium acetate. When heated with NaOH and CaO, that is a soda lime mixture, it gives the methane plus sodium carbonate. So that is the decarboxylation reaction. Next reaction is a reduction of carboxylic acids. So carboxylic acids are reduced to primary alcohol by using powerful reducing agents like lithium aluminum hydride. Carboxylic acid can also be reduced by using diborane, but diborane does not reduce ester, nitro and X groups. So sodium borohydride, that is NaBH4, does not reduce COOH group. So therefore lithium aluminum hydride is the best reducing agent for the carboxylic acid into primary alcohol. So RCOH is a carboxylic acid. When treated with lithium aluminum hydride in the presence of dry ether, we get RCOH, that is a primary alcohol. in this reaction, primary alcohol is obtained. So only general equation is given. We can write particular example for this. If we take R group as a hydrogen, then acid is formic acid. When treated with lithium aluminum hydride in the presence of dry ether, it gives HCH2OH, that is CH3OH methyl alcohol, and it is a primary alcohol. So that is about the reactions of carboxylic acids, and that is about this chapter, aldehyde, ketone and carboxylic acids. Thank you.